How do you construct a 130-foot temple without laying a single brick? How did ancient engineers carve intricate details into a vertical cliff face using only primitive iron tools? I promise to break down the terrifying genius behind Petra's Treasury and reveal the method that modern engineers are just starting to fully understand. Welcome to the breakdown. We are looking at one of the most beautiful structures in human history. But to understand it, you have to stop thinking like a builder and start thinking like a sculptor. A massive mountain-sized sculptor. Imagine standing in the middle of the Jordanian desert 2,000 years ago. You are a Nabatean engineer, and you have a crazy idea. You don't want to build a temple that looks like it belongs to the earth. You want one that looks like it grew straight out of the rock, as if the mountain itself decided to form a palace. But here is the problem. You aren't stacking stones on top of each other. You aren't putting a roof on walls. You are doing the exact opposite. You are taking a solid sandstone mountain, and you have to remove everything that isn't the treasury. Think about that for a second. Usually, when you build a monument, you start at the bottom and go up. You make the ground floor, then the second floor, then the roof. Gravity works with you because you are building on a stable foundation. But at Petra, gravity is your enemy from the very first second. The treasury, or al-Khazna as it is known, isn't a structure sitting on the ground. It is a massive cavity carved into the living rock. The immediate problem is simple but terrifying. If you cut away too much rock from the wrong place, the whole cliff face collapses. We aren't talking about a small collapse. We are talking about millions of tons of sandstone crashing down. If you made a mistake in the structural integrity, the entire facade would be buried, along with every worker standing beneath it. The margin for error here was absolute zero. There is no close enough in mountain carving. One weak spot in the sandstone, one crack that expands the wrong way, and centuries of work vanish in a landslide. So, how do you even begin? The first thing you have to understand is the material itself. Sandstone is tricky. It isn't solid granite. It is made of compressed sand grains, and it has layers. Some layers are hard as stone, and others are soft as chalk. If you carve too fast into a soft layer, you lose the sharp details. If you hit a hard layer, your iron chisels just bounce off. The Nabateans didn't have diamond-tipped saws or jackhammers. They had simple tools, likely made of iron, and they had the heat of the sun. They probably used fire to heat the rock and then cold water to shock it, cracking it so they could break it away faster. But doing that on a vertical cliff? That is a recipe for disaster. Now, let's talk about the sheer scale of this problem. The facade is 130 feet wide and about 130 feet tall. To give you some perspective, that is about the height of a 12-story office building. But an office building has an elevator shaft, a steel skeleton, and a blueprint that tells you exactly where every beam goes. The treasury has nothing but the rock it is carved from. The workers had to hang from ropes, probably sitting on simple wooden scaffolding tied off to the top of the cliff. One slip, and you fall to your death. One swing of a hammer that goes too wide, and you damage a statue's face that you can't fix. The really scary part isn't even the carving. It is the hollowing out. The treasury looks like a building, but behind that beautiful face are two massive chambers. You are standing in front of a solid wall of rock, but behind it is a huge empty room. Think about the engineering challenge there. You have to cut a doorway, then go inside and start digging out the interior, while the roof of the temple is hundreds of tons of rock sitting directly above your head. In a normal building, you put the roof up last. Here, the roof is the first thing that exists. You have to remove the pillars inside without making the roof fall down. It is like trying to take the middle out of a table without the top dropping onto your plate. This creates a paradox that baffled people for centuries. If you start carving at the bottom and work your way up, you have a massive amount of weight pressing down on your work area. As you hollow out the rooms, the columns holding up the mountain above, you are under more and more stress. It is incredibly risky. If you slip and cut a load-bearing beam by accident, the ceiling comes down. So, did they start at the bottom? Or did they somehow start at the top and work their way down? Historians have argued about this for a long time. If you start at the bottom, how do you reach the top to carve the intricate urns and statues? You can't put scaffolding in front of a building you haven't finished carving yet because there is no ground to attach it to. The cliff is steep. If you are standing at the bottom, the top is 130 feet straight up into the air. You can't just reach up there. You would have to climb up the sheer rock face, tie yourself off, and dangle there while swinging a hammer. That sounds impossible. But if you start at the top, you face a different problem. You have to climb to the summit of the mountain, which is way above the actual Treasury facade, and then rappel down to start carving. Then, where do you put the debris? As you carve the top, the rocks fall down. If you are working on the middle section, the debris from the top is falling on your head. The logistics of this are a nightmare. Imagine the noise. Imagine hundreds of workers chipping away at the stone. The sound would be deafening. The dust would be blinding. And every single chip of rock that falls has to go somewhere. If you are at the bottom, you are buried in rubble. If you are in the middle, you are blocking the people below. You need a system to move tons of waste rock out of the way, and you need to do it without killing anyone. And let's not forget the precision. Look at the columns of the Treasury. They are fluted, meaning they have vertical grooves running down them. They are perfectly straight. The statues on the second level are in proportion. The symmetry is flawless. How do you keep perfect symmetry when you are carving by hand into a natural rock face that isn't even flat to begin with? The cliff face at Petra isn't a perfect canvas. It is uneven, rough, and curved. They had to level the entire vertical surface by hand before they could even draw the first line of the design. They didn't have laser levels. They likely used water or primitive plumb lines, but doing that on a grand scale in the desert wind is incredibly difficult. So we have a problem of scale, a problem of gravity, a problem of tools, and a problem of debris. But the biggest problem of all is the unknown. When you carve a statue from a block of marble, you know what is inside the block. It is usually consistent, but a mountain is full of surprises. There could be cracks inside the rock that you can't see from the surface. There could be hollow pockets. Large stones could be loose inside the cliff, waiting for a chisel to hit them and bring the whole thing down. The Nabateans didn't have X-ray machines or sonar to see inside the mountain. They were blind. They were gambling with their lives that the mountain would hold together. This leads to the mystery that kept experts awake at night. The visible surface of the Treasury is flawless. It looks like it was just placed there yesterday. But the approach to get that result remains a mystery that leaves us asking one huge question. Did they really start at the bottom? Or was there a hidden anchor point at the top we are missing? Because if they started at the bottom, the logistics of reaching the top seem impossible. And if they started at the top, the risk of crushing the work below seems too high. It is a catch-22, a deadlock of engineering. The more you look at it, the more impossible it seems. The details are so fine that they look like they were carved with a knife rather than a hammer and chisel. The corners of the stones are sharp. The leaves in the capitals of the columns are thin and fragile. If they used heavy tools to remove the bulk of the rock, how did they switch to such delicate work without shattering the remaining stone? The change in technique would have had to be instant and flawless. And consider the water. Petra is in a desert, but it is famous for its flash floods. The Treasury sits in a canyon that funnels water directly toward it. Even 2,000 years ago, they had to protect their worksite. If a flash flood came while they were carving, it could wash away the scaffolding, drown the workers, and even undercut the foundation of the cliff itself. They actually built a dam and a tunnel system to divert the water, which is a whole other engineering marvel, but it highlights how hostile the environment was. They were fighting the mountain, the gravity, and the weather all at the same time. So, put yourself in the shoes of the master builder standing at the base of that cliff 2,000 years ago. You have a vision of this beautiful temple in your head. You have a workforce of hundreds, maybe thousands. You have iron tools and courage. But you are staring at a blank vertical wall of red sandstone that dwarfs you. You know that one mistake means death. You know that the logistics are a nightmare. How do you make the first cut? Where do you tell the first man to swing his hammer? This hesitation, this moment of where do we even start, is the problem that defined the entire project. It is the barrier that separates a cool idea from a world wonder. Most people would look at that cliff and say, let's build it over there on the flat ground instead. But the Nabateans said, no, it has to be right here. It has to come out of the rock. That arrogance, or perhaps that brilliance, is what we are here to unpack. They found a way to turn the mountain into a cathedral, but to do it, they had to solve the puzzle of the starting line. We still haven't answered how they managed the weight of the mountain while hollowing out the rooms. If they cut from the outside in, the pressure would have been immense. If they cut from the inside out, they were blind. This tension required a solution so counterintuitive that it feels like a violation of physics. It required a way to defy the very nature of how we build things. So as we look at this flawless facade, remember the invisible enemy, gravity. It is always there, pulling down, trying to destroy the work. The question is, how did they trick gravity into letting them finish? The answer changes everything we think we know about ancient engineering, and it is exactly what we are going to dig into next. What happens when you chip a piece of rock off a cliff and it falls on your best friend? How do you keep your hand steady when one slip means a 12-story drop onto solid stone? I promise to put you right in the middle of the most dangerous construction site in history and show you why the builders of Petra were either geniuses or absolutely crazy. Let's zoom in on the workspace. Visualize the worksite. It is 2,000 years ago, and you are standing on a narrow ledge suspended 100 feet in the air. The first thing you notice is the noise. It is not the quiet hum of a modern machine. It is the deafening clang of iron against sandstone, echoing off the canyon walls until your ears ring. There are hundreds of men working above you, below you, and beside you, all swinging hammers. The vibration alone is enough to make your teeth chatter. Every time a hammer hits the rock, the entire cliff face shudders. You can feel it through the soles of your sandals. And that is where the real agitation begins. You are constantly aware that the mountain is moving. The agitation here is the sheer danger and the logistical nightmare of the task. As you carve deeper into the rock face to create the interior chambers, you risk compromising the exterior wall holding you up. Imagine you are one of the workers tasked with hollowing out the main chamber. You are standing inside a dark, dusty room that is slowly being born out of solid stone. Above your head is not a plaster ceiling, but hundreds of feet of heavy, layered rock. If the Nabateans had carved from the ground up, the weight of the upper rock would have crushed the lower chambers before they were even finished. It is like trying to hollow out the inside of a watermelon while keeping the rind perfectly intact, except the watermelon weighs as much as a skyscraper and you are inside it. Think about the debris for a moment. In a normal building project, you bring materials asterisk and asterisk. You bring bricks, wood, and stone to the site and stack them up. But here, you are taking material asterisk out asterisk. The treasury is essentially the absence of rock. Every square inch of that beautiful facade represents rock that had to be removed and thrown away. And you have a team of men at the top chipping away. The guys at the bottom are going to be buried in an avalanche of falling rocks. You have to stop work at the top, just so the guys at the bottom can clear the rubble. But stopping work costs time and money. It creates a chaotic, dusty, dangerous environment where looking up could mean losing an eye or worse. Now, consider the scaffolding. We have found small holes carved into the rock face around the treasury, which suggests they used wooden beams to build platforms. But you can't just take a break whenever you want. You are part of a massive machine. The rhythm of the work keeps going, and you have to keep up, dangling over the edge, squinting in the blinding sun, trying to carve a perfect straight line into a surface that is burning hot to the touch. Imagine carving a beautiful, intricate column, and suddenly your chisel punches through into a hollow cavity or a pocket of soft, crumbly sand. You can't fix that. You can't put the rock back. They were gambling that the mountain was solid enough to hold the design, but they had no way of knowing for sure until they were already committed. This leads to a terrifying paradox. You need to hollow out the inside to support the outside, but you can't reach the inside without destroying the outside. If you carve the outer face first, the rock behind it is still solid and heavy. They had to sculpt the interior last, but working inside those tight, dark, confined spaces while the ceiling looms above you is claustrophobic in the extreme. Let's not forget the dust. When you chip away at sandstone, you don't get big chunks. You get powder, fine, red, gritty powder. The agitation doesn't stop at the physical danger. There is also the mental torture of the timeline. This wasn't a weekend project. It likely took decades, maybe even a lifetime. The master architect who designed it probably never saw it finished. Your elbows ache, your wrists throb, and your shoulders are on fire. This tension required a solution so counterintuitive that it feels like a violation of physics. The situation seems impossible. If you work from the top down, the falling debris kills the progress below. If you work from the bottom up, the weight of the mountain crushes your work. Every logical way to build this structure leads to a dead end. The workers are trapped between the hard rock and the hard place. It gets worse. It is beautifully carved, but look at the bullet holes. Local Bedouins believed there was treasure inside, so they shot at it to try to break it open. But if they are working from the bottom up, how do you carve a stone urn that sits 130 feet in the air on a tiny ledge? This suggests the top-down method, but as we established, that brings its own set of terrifying problems with debris and scaffolding. It feels like it shouldn't be possible. It feels like there is a piece of the puzzle missing. We see the beauty, but we miss the terror that went into making it. The logistics were a nightmare, the engineering was suicidal, and the physical toll was devastating. It is a miracle that anyone survived, let alone that the structure turned out to be perfect. This creates a terrifying paradox that still leaves us with one huge question. How did they keep the mountain from crushing them? The deeper you go into the problem, the more impossible it seems. The answer to the mystery of the debris, the danger, and the direction of the work is coming up. I promise to show you the single engineering trick that solved the impossible gravity puzzle of Petra and explain why everything you thought about building is backwards. But what if I told you the Nabateans never actually hung off ropes to build the main facade? The solution is so simple it hurts, but it requires you to completely flip your brain upside down. They didn't build up. They didn't even carve in. They carved down. This is the top-down method, and it answers the question of the hidden anchor point we asked earlier. The anchor wasn't a hook or a bolt driven into the rock. It was the summit of the mountain itself. They started at the very top peak, way above where the Treasury stands today. If you go there now, you can see it. It is a high plateau looking down over the canyon. The workers didn't start at the bottom. They started at the top, standing on solid, flat ground. They were safe. They were stable. Picture the scene. The top of the cliff is flat. The master builders mark out the width of the temple on the very edge. The workers start chipping away the rock, carving the very top of the pediment, the highest point of the temple. But here is the genius part. As they carve the face of the temple, they are also carving a massive sloping ramp. They aren't removing the rock and throwing it away into the empty air. Imagine the ground level is at the top. They stand there and carve the top 10 feet of the temple. Then they dig out the rock behind it, creating a ramp that slopes down. They move down the ramp 10 feet. Now they are standing on a new ledge. They carve the next 10 feet of the temple facade. The entire worksite is at the bottom of the pit, which is actually the top of the structure. You just kick the rubble down the slope you are creating. It falls away harmlessly to the bottom of the future canyon, clearing your workspace instantly. No buried workers. No dangerous avalanches on top of people's heads. Second, the safety. They are never hanging by a rope. They aren't looking down a death trap. They are looking at a wall of rock in front of them, standing comfortably on the ramp they just built. Third, and most importantly, the structure. The roof is finished first. The walls are finished next. The columns are finished last. This means the weight above is always settled and stable before you touch the rock below it. The mountain never crushes you because you are always removing the support from underneath asterisk. After asterisk, the upper part is done and holding its own weight. As they dug this massive trench, following the ramp down layer by layer, the treasury didn't grow. It was revealed. Imagine walking by this site 2,000 years ago, before it was finished. You see a cliff, but there is a strange stepped trench cut into the side of it. Every day, the trench gets deeper. Every day, a little bit more of the building appears at the bottom. It must have looked like the building was rising out of the earth, or like a ghost taking form in the stone. The beauty was always there. They just had to find it by removing the ugly rock around it. But the ramp wasn't just for digging. It was also a road. Think about the logistics. You need to get fresh workers up to the worksite, and you need to get the broken rock out. A sloping ramp allows both. Donkeys or carts could potentially carry away the heavier chunks of debris, or workers could simply slide them down the slope. It created a continuous flow of traffic that kept the project moving. If they had used ladders or ropes, it would have taken hours just to get a single worker into position. With the ramp, they just walked up. Now, we need to talk about the final step, because carving it out of the rough rock wasn't enough. If they stopped there, the treasury would look like a jagged, ugly hole in the mountain. To turn it into the masterpiece we see today, they had to master the art of lishing. The Nabateans didn't just use hammers. They used the hardness of the rock against itself. Once the main shape was cut out, the rough surface was covered in tool marks. To fix this, they likely used rubbing stones and sand. They started with rough, heavy stones to grind down the deep ridges left by the chisels. Then they moved to finer stones. Then they used sand and water, perhaps using leather or cloth as a buffer, to buff the surface. They polished the sandstone until it was smooth as glass. Think about the dedication this took. You are not swinging a hammer anymore. You are rubbing a rock against a wall for hours and hours, day after day. It is a quiet, repetitive work, but it is what separates a cave from a cathedral. When the sun hits polished sandstone, it glows. The red hues turn into bright oranges and pinks. It catches the light. If you saw it back then, when the sun hit that facade, it wouldn't look like red rock. It would have looked white or gold, blindingly bright against the dark canyon shadows. It was designed to dazzle. And here is where the mystery of the hidden anchor point resolves completely. The anchor was the top of the mountain. By starting there, they controlled the entire project. They dictated the angle of the walls. They dictated the symmetry. They never had to guess if the top was straight, because the top was where they started. It was the reference point for everything below it. This brings us back to our original question about the unknown inside the mountain. By carving from the top down, they could see the layers of rock as they went deeper. If they hit a soft spot, they could adjust the thickness of the columns or the depth of the wall before they went any lower. They were constantly checking their work. They were adapting to the stone in real time. If a crack appeared, they could stop and fix it before it became a disaster, because the weight of the rock above was already gone. They were working in a stress-free zone of their own creation. So, how did they keep the mountain from crushing them? They didn't fight it. They used it. They let the weight of the mountain work for them by starting at the top. They obeyed the laws of physics so perfectly that they turned a dangerous, chaotic landslide risk into a controlled, predictable excavation. It wasn't just construction. It was subtraction. They removed the universe to leave only the masterpiece. The realization of this changes how you look at the treasury forever. When you see a photo of it now, don't just see a building. See the negative space. Imagine the ramp that used to be there. Imagine the tons of rock that are gone. Imagine the workers standing on the slope, comfortable and safe, carving the details that we admire today. The beauty wasn't added on. It was revealed by patience. The real tools they used weren't just iron chisels. They were patience, planning, and a deep understanding of how stone behaves. They accepted the limitations of their technology and beat them with sheer logistical brilliance. They turned the mountain into their workspace, and then they removed the workspace to leave the art. And that is the lesson of Petra. Sometimes, to build something incredible, you don't need to add more to the world. You don't need bigger machines or taller cranes. You just need to chip away everything that isn't the masterpiece. You have to be willing to start at the top and do the hard work of removing the obstacles, piece by piece, until the beauty underneath is finally free. The Treasury isn't a structure built by hands. It is a mountain set free by them. And that is why, 2,000 years later, it still leaves us speechless.